Okay, the next one. A-13, it says, a nutcracker, 16 centimeters long, is used to crack open a Brazil nut that is placed 12 centimeters from where your handle is squeezed. Okay? From where your handle is squeezing the nutcracker. So your hand's here, so it's 12 centimeters. Okay. Okay. And what is the ideal mechanical advantage of the nutcracker? It all has to do with the fulcrum. This value here, the DI, is going to equal the total length of the nutcracker. So that's 16 centimeters. Yes? The DO is the distance from the fulcrum. Is this on? Yes. Is it on? It is? Okay. Is the distance from the fulcrum to the nut. This is where you're putting the nut, right here. Okay? Right? So it's going to be 3 centimeters. No, sorry, 4 centimeters. 4 centimeters, sorry. It'll be 4 centimeters. You see that? This is where the nut's going to go here. Correct? So it's going to be 4 centimeters. So the nut will be like in here, whatever. But anyway, the IMA equals the DI over the DO. And in this case, you can do this in your head, okay, unless you're asleep, okay, is going to be 16 divided by 4, which is what? 4, right? Is that correct? Okay. So the answer is 4. Any questions on that? Pretty straightforward. Levers. It's okay? All right, let's do the next one. You're still okay, but I just want to come in here a little bit. Is that okay? You okay with that? You move back a pinch. Okay, this one's a little bit more complicated, and it has to do with salmon. It has to do with salmon. Okay. It says a 5-Newton salmon swims, 5-Newton salmon, that's the weight of the salmon. A 5-Newton salmon swims 20 meters upstream 20 meters. It's on a rise. And the resistance force is 1.5. Let me write over here. So we're going to call it the resistance force equals 1.5 Newton. I hope that's self-explanatory. Okay? So it has a resistance force of 1.5 newtons. This portion of the stream rises at an angle of 10 degrees, correct, with respect to the horizontal. Now, what I did was, I helped you out a little bit. Well, we did it together before I started filming this, but, so the height, this height here is 3.5 meters. That's the height that the fish is going to go. Every 20 meters, with that angle, it's going to go to a height of 3.5 meters. So, it says, how much work is done by the salmon against the currents? So, if I push on an object, let's say an object, I'm pushing on an object, and here's a chair. I don't know if you can you see the chair on the film? Okay, all right, I'm pushing on. I'm pushing on a chair. Okay, pushing on a chair. And and the chair's pushing on me 1.5, that's the resistance. So I'm pushing 1.5 on the chair, correct? That's the resistance, correct? It says specifically the current that provides a resistance of 1.5 newtons. So the fish has to at least apply that much, in terms of Newton's third law, that much force, correct? So the work that the fish does against the current will be 1.5 times 20. So the work, we'll call it, the work the fish does is force times distance, which equals 1.5 newtons times 20 meters, correct? So what's that? What is that? What's 20 times 1.5? 30. So the work the fish does is 30 newtons. Okay, easy peasy, lemon squeezy. Okay, so that's A. B, what is the gain in potential energy? What is the gain in potential energy? So the delta PE is mgh, right? What's mg of the fish? What is the gain in PE by the salmon? Isn't 5 newtons mg, correct? So it's a 0.5, so it's a 0.5 kilogram fish, small, not too small, it's a pound in English measurements. So it's going to be a 0.5 kilogram fish, and times 10, that's mg, isn't it? So what is mgh? So this is going to equal 5 newtons times a height of 3.5 meters, and that's going to be the change in potential energy. And the change in potential energy would be 5 times 3.5, which is what? What is 5 times 3.5? Anybody? I just happen to have that answer here. Do you have the answer over there? 5 times 3.5?
Yes.
What do we got?
17.5.
17.5? Anybody want to verify that? I trust you completely. Yes?
That's correct.
17.5. 17.5 joules, right? Correct? Yes? All right, can I erase the amount, in case I kick the stool. You don't want that thing. So, what's the last question? It says, C, what is the total work that must be done by the salmon? What is the total work that must be done by the salmon? The total work that must be done by the salmon. So, anybody? Can anybody help me out here? Can I erase this? What's the total work that must be done by the salmon? Well, it's right here. It's this change in potential energy, correct? And because the current, this is the potential energy change, 17.5, correct? And because you have this work that you're doing against the current, you have to add that. So you're adding two things. So it's going to be the total work is going to equal the work of the fish plus the change in potential energy, and that's going to equal what? 47.5 joules, right? That's the total work. I think we may have to tilt the machine slightly. Mary, if you could just move in a bit, okay, huh? Thank you. And I'll just turn it a little bit. There we go. Clear? Any questions? No? Yes? Maybe? Could be? All right? All right. Let's do one more.